All right, we are back. So quick recap, if you haven't already watched the other video, it was a quick 5-minute video on just figuring out the first step. We've got to figure out, is our parabola opening up, right? Y equals x squared is going to open up. It's the one we're familiar with from algebra 1, right? It's going to, whoa, sorry. How do we make that small again? There we go. Is going to open down. It's going to open down. It's going to have a negative coefficient, and it's going to be y equals x squared, right? So we're familiar with that. Like a reflection of a parabola is going to reflect over and open down. Now, if you have of this form where it's a linear x and it's y that's squared, we're going to be opening right because positive numbers are to the right. It's going to open that way, and negative is going to open left. So whenever I do a parabola, I always just try to figure out which way is it going to open, up and down or right and left. Now to add on to that, every parabola has a focus and a directrix. The focus is always inside the parabola, so that's important. So here, we're going to have our focus somewhere inside the parabola and our directrix outside on the opposite direction, right? So if this is p units to the focus, it's going to be p units to the directrix in the other direction. Here, our focus is going to be inside, right? P units to our focus, p units back to our directrix. And the directrix is the dashed line. All right, we don't usually draw those bumps, sorry. Okay, so our focus might be somewhere here. Our directrix is going to be the opposite direction, right? So if our focus is to the right, the directrix is in the opposite direction. It's always going to be, the vertex is going to be equidistant from the focus and the directrix. Here our focus would be on the inside, our directrix would be over here. Okay, so that's kind of the basics of what a parabola is going to look like. All right, so we didn't talk about converting this equation. Okay, now all the parabolas that I drew, they had a vertex roughly around 0, 0. So we're going to move away from the origin since we are in honors geometry. Active Inspire, you can do it. I believe in you. You can do it. It doesn't want to respond. Okay. Maybe we will try a different method then. Let's try stop sharing. Oh, you don't need to see me that big. Whew. Okay. How do I get back? You're going to see me trying to figure this out. All right. I just want, I hit stop sharing. Make that big again. Okay, here we go. Let's try a whiteboard instead, huh? Okay, let's try that. Maybe that'll work better. I don't know. We'll see. Move me over here. Okay. I believe on the next slide we had, let's see. So x minus h quantity squared equals 4p y minus k. Okay, so we had that. We also had y minus k. Notice though k always stays with the y squared equals 4p and x minus h, and the h always stays with the x. Okay, now sometimes you're going to see these equations written in a different way. Instead of this, you're going to see solve for y, like get y all by itself, right? So if I want to solve for y, and really in this case, I'm going to solve for y minus k, but if I get that all on the same side, y minus k, that quantity is going to be equal to, I would divide both sides by 4p, right? Divide by 4p. So sometimes you'll see this, 1 over 4p times x minus h squared. All right. And over here, divide by 4p, it would be x minus h equals 1 over 4p times y minus k. Sorry, that was a lot. Ooh, squared. That was a lot. Okay, so real quickly, all I did to kind of convert this was divide both sides by 4p. So this equation has y like in this form, y equals x squared, right? With a lot of transformations and some p in there. And here we have x equals y squared. So whenever I see a problem, I want to kind of orient myself. Am I looking at a y equals x squared, where the parabola is opening up or down, depending on whether it's positive or negative, or am I looking at an x equals y squared, where it's opening right or left, depending on whether it's positive or negative? Okay. All right, so let's do a problem. Let's say, it'd be nice if I could see my flip chart that I had all prepared for you. Let's see if it's finished. Okay, all right, so this is they're showing us the distance P, right? P is from the vertex to the focus, or the vertex to the directrix. They also talk about this axis of symmetry, which, right, it cuts that parabola in half, and it's symmetric. The one thing it doesn't say on here is something called the latus rectum. I know, it's just such an interesting word there. The latus rectum is this distance right here. And that's important because we want to draw 3 points for our parabola. We want to draw our vertex and the 2 points, the 2 endpoints of that lattice rectum. And how we get there is we have 1p is that distance, but then I go twice p up and twice p down in this situation to find those 2 endpoints. Over here, here's my vertex. I go up to my focus, and I'm going to go twice p to the right, 2p, to find that point, and I'm going to go twice p to the left. And you might be asking, why? Why is it always like that? And I'm going to answer why, because I want to know the why too. And the reason why is the definition of a parabola. So if I go twice p, and this is not drawn to scale very well, but this distance twice p is the same as the perpendicular distance here, which is twice p, right? We know that height is 2p away from, okay, the parabola is the set of all points that is equidistant from a point and a line. So no matter where I am, if I click on this point right here, sorry, my pen is not working very well. If I click on that point right there and I draw a line from the focus there and from that point down to the directrix, these 2 lines are an equal distance. And this is not drawn to scale, so it doesn't look like they are the same, but they are the same. So this height is 2p, this is 2p, so that distance and that distance are equivalent. Okay, so this twice p has to do with this square, right, that is formed, this equidistant property. Okay, all right, so let's move on and try some practice problems. Okay, you can do it. I need to update my Inspire software once I can figure it out. Okay, yay, thank you. All right, graph each equation. So y equals x squared. I'm thinking, all right, is this the one I'm familiar with? Y equals x squared. Yeah, that's like when I think normal. I know what's normal, but y equals x squared. That's like my normal parabola. Okay, but it also, the formula is y minus k equals 1 over 4p times x minus h squared. So that's like the format. So I look at my HK and I think, okay, well there are no parentheses, there's no quantities. So we haven't moved away from the origin. In this situation, we're just looking at the vertex at the origin. So my HK is 0, 0. So the vertex in this case is 0, 0. All right, but I also need to say, okay, that 2 value right there, that 2 is equivalent to this right here. Okay, so 2 equals 1 over 4p. So I'm going to solve that. 2 equals 1 over 4p. All right, so I need to get p by itself. I'm going to multiply both sides by 4p to get that out of the denominator, times 4p. That cancels, and here I have 8p equals 1. Oh my gosh, I'm going to divide by 8, and it looks like p equals 1/8. That is super, super small. Wow, okay, so I need to go, so p is 1/8, so it means from my vertex to my focus, it's 1/8. And we said, did we decide is it opening up, down, right, or left? You're right, we haven't said, okay, but we know it's up or down, right? Because it's y equals x squared. It's up if the p-value is positive, and it's down if the p-value is negative. And this is a positive p-value, right? So p equals a positive 1/8. Okay, so it's opening up, which means if this is my vertex, I'm going to go 1/8 up. Oh my goodness, it's so tiny, I can't even see it. Okay, I'll need to do a different color so you can see what I'm doing. 1/8. My stylus is not good enough to show 1/8. Okay, and then 1/8 back. Oh, okay. You know what? Did I make another page with a better graph for this? You know what? I'm scrapping this graph. I'm going to draw a white box and do it myself. Come on. Oh, now it's not responding. Okay. Let's go back. We can do this. Y equals 2x squared. We're going to share the screen. Share. Okay, getting the hang of this. Y equals 2x squared. We decided the vertex was at 0, 0. And we decided p was a positive 1/8. So when I make my graph, my vertex is at 0, 0, right? Oh my gosh, that does not at all look like a point. Okay, let's do a little thicker. Okay, and let's say this is 1. Oh no, we're on the highlighter. Okay, this is 1. So 1/8 is going to be, let's say, about here. All right, and back 1/8 is going to be my directrix. So my directrix is the line y equals -1/8. And my focus is at 0, positive 1/8. Focus is at 0 in the x and a positive 1/8 in the y. So that's my focus. Now, how I get to my two other points, the endpoints of my lattice rectum, we need to go twice p to the right and twice p to the left. So we're going to go 1/8 plus 1/8, which is 2/8, which simplifies to 2/8 simplifies to 1/4. So we're going to go, if this is distance is 1, then that's 1, and that's 1. I'm going to go 1, so up to the focus, 1/4 to the right, 1/4 to the left, and I'm going to go through that point, through the vertex, and through that point. Sorry, I missed the first one a little bit. Okay, this is my focus. It's supposed to be a circle point. That is the focus inside the parabola. Okay, so that would be, I would need to maybe label these better. This is 1, this is -1/8. Why we started with such a little one, I don't know. What was I thinking? That's positive 1/8. We went over 1/4 to the right and -1/4 to the left. Okay, let's try it. All right. Sorry. Okay. All right, let's try this one. So this was opening up, right? It was really little. It looked like this, something like that, right? Okay. And the directrix is really 1/8. Whew. Okay, let's try this one. So here, instead of y equals x squared, now it's x equals y squared, and that's the one I'm like, what? That does not look right to me. Okay, so that's where I'm like, oh, this is one of those right and left parabolas that technically isn't even a function, right? Because it doesn't pass the vertical line test, but conic sections, we've got some that go right and left. Okay, So y equals, it's not something you can plug in your calculator easily. So we're going to go x equals 1/4 y squared. Okay, remember our formula. This is very similar, but it's x and y are switched, right? Again, our vertex is at 0, 0. So we've got right there, and then what else? So this is 1/4p. 1/4p is equal to 1/4, right? 1/4 is a coefficient, and that is equal to 1/4p. So I can just kind of common sense think about that and say, okay, 1/4 times some number is equal to 1/4 times what? Well, the only number that's going to make that make sense would be if p equals 1. All right, there's other ways you could cross multiply if you weren't sure about it. In this case, p equals 1. All right, so that distance p is 1. Our lattice rectum is going to be 4 units long because we're going to go twice p to the right and twice p in this case up and twice p down. So we end up going 4 times the length of p. All right, so let's try this. Okay, so again, our vertex was at 0, 0. And I decided, is it up, down, right, or left? We said right or left, but we didn't narrow it down. So if it's positive, it's opening to the right, and negative, it's opening to the left. It's positive, so we're looking at this one. Okay, which means I'm going to go 1 unit, p is 1. I'm going to go 1 unit to the right, that's my focus. I'm going to go 1 unit to the left, that's my directrix. So directrix is here it crosses the x-axis, so it's going to be x equals -1 is my directrix. It's a line, it continues, so I'm going to put arrows. At +1, that's my focus. So my focus is at the point 1, 0. And then in order to get my 2 other points that I need to graph through, what I'm going to do is I'm going to go from my focus, I'm going to go twice p, which means up to the above, and twice p below. And then from my vertex, I'm going to go from my vertex and go through those 2 points. Okay, make sure your focus should be inside. Focus is inside the parabola. Directrix is on the opposite, right? So one mistake I've seen students do is they'll put the focus inside, and then they'll put the directrix like right on top of it. So directrix on one side, focus on the inside. Focus is inside the parabola. Directrix is on the opposite side. All right, let me undo. Sorry, those red dots are not correct. Never leave bad math. Oh, I heard something the other day. That was really cute. Some online video of a homeschooling parent. They said, my kid's teacher said math stands for, what did they say? Mistakes allow thought to happen or something like that. I was like, wow, that's so cool. Mistakes allow, I wrote it down. I'll have to look it up and share it. Great. Okay, sounds like something I would say. Okay, so now what if we were given some information like, okay, the vertex is at the origin. Oh, am I on a pen? Vertex is at the origin, and the directrix is at y equals, so here's my x, I'm not going to go there, y equals -1/2. So if my directrix is here, what does that tell me? If I know where my vertex is, I know where my directrix is, what other information do I know? I also know where my focus is, because this distance is p, right, or it's -p. This distance is p, right? The absolute value of that distance is p. So if I went a ½ unit down, I'm going to go a ½ unit up to get to my focus. So I know my focus is at the point 0, +1/2. All right. I also know 2 more points because I need to take that 1/2 distance and I need to double it. So 1/2 doubled would be 1 whole. A half plus a half is a whole. All right. So I'm going to go twice p to the right, up to the focus, twice p to the right, twice p to the left. So 1 to the right, 1 to the left, and then I can go through the endpoints of that lattice rectum and through the vertex. The focus should be inside the parabola. All right, so that would be my graph. Now, if I wanted to write the equation of that, let's do that. Okay, so what did we say our p-value is? Is it positive or negative? It is a positive value. Good. P is a positive 1/2, right? Because it's always, the p-value is always from the vertex to the focus, because that's our direction. We're pointing up, so it's a positive value. All right. Okay. So is this a y equals or an x equals? So y equals x squared. Yep. So y equals x squared, and we didn't move away from the origin, so we don't need to worry about that minus h and minus k yet, right? But it's also 1 over 4p. 1 divided by 4p. Now wait a second. I need to plug that in. 1 over 4, the p is 1/2, so what's half of 4? Half of 4 is 2, 1/2. Okay, so in my equation, it's going to look like this. Which kind of is a little odd because that is p, right? It turned out that way. It doesn't always turn out that way. So, all right. So that would be our equation of our parabola. If you want to graph that on the calculator and check it and see, you could. All right. Let's see. I think we have one more practice problem, then I'm going to wrap it up. And hopefully that will help you a little bit to get focused on parabolas better. All right. This needs a second. I hope you are doing well. I know this is not ideal. It's nicer to be in the class where you can ask questions and all that wonderful stuff, but I'm here for you. Feel free to email. Okay. I know I don't always get things up as quick as you'd like me to, but I've got my hands full. Okay. So let's make this bigger so we can see it better. Okay, we have a little information here. It says, oops, there we go. Okay, it says the vertex is at 2, 3. So I'm going to go over 2, up 3. That's where my vertex is. Okay, maybe I even like label it with a V just so I can like remind myself that's a vertex. Okay, and then the focus is at 4, 3. 4, 1, 2, 3. The focus is here. All right, and where does the focus always have to be? You're right, it has to be inside the parabola. Okay, now I know a lot of information just being given 2 points because the distance between the vertex and the focus, that distance is my p distance. So I know that p value is 2. Is it positive 2 or negative 2? From the vertex to the focus in that direction, right? I'm going a positive amount. So I'm going positive 2 units. Okay, no, p is 2. So I'm going to go from the vertex 2 to the right. You know how I said we were going to do a dance for all our conics, right? We go on the x, we're going to go right and left and up and down. And there's the roadmap. Well, the parabola dance, if you had seen me in person, would have been a very pretty dance. But we started the vertex. We go 2 to the right to get to the focus. We're going to go 2 back. I kind of don't like that there's a line there. I was just trying to show you that distance. I'm going to try to erase it. Okay. You can do it. You can do it. Okay, so vertex, focus, we're going to go back to, and that's our directrix. Now it ends up, it's right on that y-axis. So I'm kind of drawing it off so you can see it, but it should be right on that y-axis. So that value is where x equals 0, right? All of those points have x equal to 0. All right, so we've got our focus, our vertex, our directrix. We need 2 more points. So we go out to the focus, go twice p. So 1, 2, 3, 4 units up. Put our endpoint of our lattice rectum. We're going to go 4 units down. 1, 2, 3, 4. Twice p down. Okay. Then I'm going to draw my parabola. Whoop. Whoop. Come on, pen. You can do it. Uh-oh. What happened? Okay. Let's go back a page. There we go. Okay. So we're going to go through. Okay. We can do this. Let's get a pen. Practice patience. Deep breath. Okay, we're going to go through those 2 points that we drew. We're going to put arrows on the end because it continues. Okay, I think that's it. All right, let's write the equation. All right, that's a good one. Okay, so we know the vertex is at the 2, 3. So that's important. Our vertex is at 2, 3. Is it, so we need to answer a couple questions, right? Are we looking at it up and down or right and left? Obviously, we can see it's a right. Okay, so right and left. Here we have y equals x squared, and here we had our x equals y squared, right? Is it the ones I'm used to from algebra 1, or is it those other ones? It's the other ones. Okay, so I'm gonna start an equation looking like this, but I'm gonna be careful and put some parentheses like that. The y is the one that's squared, the x is not squared, right? Okay, now I need to put my h comma k. I have to be very careful. So h goes with my x, so I'm going to put minus 2, the opposite, right? And the opposite, so I'm going to put minus 3. So my vertex is at positive 2, positive 3. And then right here, I'm going to put 1 over 4p. 1 over 4p. And I know what p is. P is 2. So let's plug that in. 1 over 4 times 2. 4 times 2 is 8. Okay. So 1 over 8. 1/8 is what I want to put there. And that would be the equation of my parabola that we just drew. Okay. I hope this has been helpful. Thank you for being patient. Those of you who have been asking for this video. All right. Take care. Feel free to ask more questions. Thanks. Oh, that didn't start recording.